These are the notes for Unit 6, the chapter on chemical reactions and equations, and these would be notes 604. And if you look at this page, 604, this is showing just a representation using letters instead of chemical symbols. A plus B yields AB. This would be a compound, and this would be an element. And then here we have a compound, and it's being broken down into its elements. So these are examples or representations of what chemical equations look like. Basically, a chemical equation is just a shorthand way of reporting the details of a chemical reaction. Chemical reaction, and I will abbreviate RXN for reaction. So this is just a short way for us to write a chemical reaction. When you have a chemical equation or a reaction, and we'll use this one as an example, the things that are on the left-hand side of the equation, those are called the reactants. So the reactants are the starting substances in a reaction, and they're always placed on the left side of the equation. Then the products, which would be over here, it's what's being produced. Those are the substances produced during a chemical reaction. And they're placed on the right side of the equation. Then if you look at this, we also have the arrow. The arrow is right here, and the arrow, when you read a chemical reaction, you would say yields. So you would say H2 plus O2 yields H2O. And then we have the coefficients, and those are the big numbers. Those are the big numbers that are in front of your elements and compounds, and these are what we use to balance the equation. And they represent the number of either moles, and we're going to talk about those shortly, formula units, or atoms of a substance. And actually, instead of putting moles there, let's just change that to molecules. All right, so that's how you break down a chemical equation. And so let's look at a couple examples. The reason we do this, the reason we write chemical equations and we balance them, is because the law of conservation of mass says mass cannot be created or destroyed. Destroyed. So whatever we start with on the left, we have to have the same number and types of elements over on the right. So if we have zinc over here, we have to have it over here. Hydrogen is here, it's over here. And chlorine is here, it's over here. So that is what law of conservation of mass says. Now, when you balance an equation, I'm going to show you an example of how to do that a couple of different ways, and you can work with whichever way is most comfortable for you. The first thing you really want to do is you want to look at what you have. You have zinc, hydrochloric acid, zinc chloride, and then hydrogen. And you need to have the same number of them on each side of the equation. Now, these little numbers were in there to balance either the diatomic element. Remember, never have fear of ice-cold beverages. Those are elements that can only be found in pairs. Or it's balancing the charges on a compound. So you can't change the subscripts, okay? So you cannot change these little numbers at all. All you can do is add a coefficient to the beginning, right here at the beginning of each one of those. If there's a 1 there, you just leave that blank because it's understood that you would have a 1. So the best thing to do is kind of make an inventory of what you have. You have zinc over here, you have hydrogen over here, and you have chlorine over here. And over here we have zinc, hydrogen, and chlorine. It doesn't really matter which order we go in. Now I will tell you, you probably want to balance hydrogens last. Hydrogens and oxygens you balance out last. So if I have zinc over here, I have one zinc here and I have one zinc here. So I can put a 1 here and a 1 here. That's balanced. Chlorine, I have 1 here, but I have 2 over here. All right, so if I have 1 over here and 2 over here, I need to make this even, and you can't get rid of one of them. So you need to do something that would give you 2 chlorines over here. If I put a 2 coefficient in front of this, that gives me 2 hydrochloric acids, which now gives me 2 of those. So I have 2 chlorines over here, and now I have 2 over here. Now let's look at our hydrogens. We have 2 times 1, because there's 1 hydrogen in the hydrochloric acid. And over here I have 2. So I have 2 over here, and I have 2 over here. That gives me 1 and 1, 2 and 2, 2 and 2. So this is balanced. So all I would need to do would be to have a 2 in front of the hydrochloric acid. All right, now if we do the same thing on this one, we've got hydrogen and oxygen on the left, hydrogen and oxygen on the right. I have 2 hydrogens over here, and I have 2 hydrogens over here. I have 2 oxygens over here, but over here I only have 1 because it's H2O. So I need 2 oxygens. I cannot put a little subscript here, so the only thing I can do is put a coefficient. I'm going to put a 2 right there. And if I put a 2 right there, let me get rid of this stuff. If I put a 2 right there, what does that do to my entire compound? Well, it doubles it. So instead of having 2 hydrogens, now I have 2 oxygens, but I have 4 hydrogens. So now my oxygens are balanced, but it messed up my hydrogens. So I'm going to go back. What can I do to make this 4? I can't make this go down to 2, but I can make this go up to 4, and I can do that by putting a 2 in front of this, because 2 times 2 of them would give me 4. So this balances with a 2 here and 2 here. All right, now you try this one. Stop the tape or stop the video and try this one and see what you get when you do that. Okay, so I'm going to write C, H, and O. Those are my 3 elements, C, H, and O. And if you'll notice, oxygen is in 2 places over here, so those have to be added up. I'm going to put a 3 here, an 8 here, and a 2 here. I'm going to put 1 carbon, 2 hydrogens, and 3 oxygens. All right, so what can I do to balance this out? Well, if I look at this, I have 4, let's say I have 8 hydrogens over here, and I have 4 hydrogens over, or 2 hydrogens over here. So if I put this as a 4, that's going to double my hydrogens and give me 8. So I'm going to put an 8 right there. All right. If I have 3 carbons over here, but I only have 1 carbon here. So if I put a 3 here, that's going to give me 3 carbons over here. I've got 3 carbons here, 3 carbons here, 8 hydrogens here, 8 hydrogens here. Now let's look at the oxygens. I have 2 oxygens over here, and now that I've changed some numbers, I have 3 times 2 is 6, plus the 4 that are over here, so I have a total of 10 oxygens on the right. I only have 2 over here. That's an easy enough fix, because if I put a 5 here, it only affects my oxygen. It doesn't affect anything else in my reaction. It doesn't affect my carbon or hydrogen. So this would be C3H8 plus 5 O2s yields 3 CO2s plus 4 H2Os. Okay, so that's how we balance. So what are the rules that we're going to use to help us figure out how to do this? First of all, if you want to, you can start by making an element inventory, which is what I did. I listed the elements underneath each one. All right, then if you want to, you can draw a box around each formula and equation, or in the equation. And if you do that, I didn't do that on those previous examples, but if you're having trouble, you might want to do that. It'll help you out a little bit. I'll show you an example. And then you begin with one of the molecules or formula units of the substance that has the most atoms. okay, of the substance containing the most atoms. And then we're going to balance any polyatomics. Any polyatomic ions that appear on both sides, that's really important that they're on both sides of the equation as a single unit. And then we're going to balance hydrogens and oxygens last. All right, so let's look at an example. If I have Cu plus AgNO3 yields CuNO3 plus Ag. All right, now if you want to, if you feel like you need to, you can put a box around these, and I'll show you why in just a second. Okay, so there's 3 that I kind of cut off, but I didn't mean to. Okay, I can't change anything inside the boxes, which means I can't put any numbers in there. The only thing I can do is put numbers out here in front of the boxes. Okay, that keeps you from wanting to put little subscripts. So now we're going to make an inventory. We have copper, silver, oops, that's not silver. We have copper, silver, and we have NO3 over here and over here. It's the same polyatomic ion, so we are going to treat that as a single element. Even though it's not an element, we're going to pretend like this is one thing because it's the same on each side of my equation. So now my polyatomics is taken care of. I'm going to start with the one that I have the most of. Well, the only thing I have more than one of is this polyatomic ion, and I have 2 of them over here and I have 1 over here. So if I have 2 over here and 1 over here, how can I make this 2? I can't put a parentheses and a 2. I can't do anything inside this box. All I can do is put a 2 out here. So I'm going to put a 2 there. Now let's just say silver. I've got 2 silvers here, but I only have 1 here. So I need to put a 2 in front of my silver. That makes those equal. Copper, I have 1 over here and I have 1 over here. So that gives me 1 copper, 2 silvers, 2 nitrates, 1 copper, 2 silvers, 2 nitrates. So that's balanced. Okay, now if you have a polyatomic ion that is not the same on each side, then you have to balance those out individually. Okay, and that would be an example like this. KNO3 yields KNO2 plus O2. So it's given off one of these oxygens. So first thing I'm going to do is I'm going to make a box around each one of these so that I can't do anything inside the box. Okay, I'm going to make my inventory. I've got K, and I can't put NO3 because NO3 is not over on the right. It's just K, N, and O. Now, I want to do my oxygens last, but when I look at this, I have 1 of these on each side, and I have 1 of these on each side. So that really isn't going to help me. But what I have over here is I have 3 of these, and I have 4 of these. Okay, now, if I have 4 of these over on this side, I have to put a number in front of my KNO3. So the first number I can put in front of that, if I put a 1, it doesn't help me. But if I put a 2, if I double this number, okay, then this is going to double my K's, and it's going to double my N's, and it's going to double my O's, which is going to affect my K's over here. I would need to put a 2 over here. Okay, so actually, that one's a little bit complicated. I'm going to wait and we're going to do that one in class together, just because if I explain it on here, I don't think you're going to understand it. So we'll just back up and we'll do that one in class together. So make sure you have that written down. The KNO3 yields KNO2 plus O2. And you try to balance it. It might take a little bit of figuring out on your part, but go ahead and try to balance it and see what you get. Okay, now let's do this one right here, where you have the sentence that gives you the equation and you have to figure out what the actual chemical reaction looks like. Hydrogen and oxygen combine to produce water. So that means hydrogen and oxygen combine to produce, that's my yields, water. So when we go through and write this down, one of the things you have to remember are your diatomic elements. And if you look right here, diatomic means that it's 2 atoms. And the diatomic elements that we have are nitrogen, hydrogen, fluorine, oxygen, iodine, chlorine, and bromine. That means they can never be by themselves. They have to be in pairs. So what you're going to do is, if you have those in an equation right here, you have to go ahead and put a 2 right there. Okay, you can't have just hydrogen by itself. So this would be H2 plus O2 yields H2O. And then we would go ahead and balance it. We would go H and O, and I think we've already done this one. I've got 2 hydrogens here and 2 hydrogens here, 2 oxygens here and 1 here. So I'm going to put a 2 in front of that. Gives me 2 of those, but it changes this to 4. And so I need to change this to 4 by putting a 2 in front of that. So we're going to practice these in class together. Okay, one last one that I want you to do before you come in is do this one, and I'm going to check that when you come in, and that's going to count as part of a quiz grade that you're going to take. This will be part of your grade, so make sure you have that filled in, and I want you to do the boxes. Carbon disulfide reacts with oxygen to produce, there's your arrow right there, so that plus this produces carbon dioxide plus sulfur dioxide. So I want you to write the equation down on your notes and do the little boxes and the inventory and balance it and see what you get. And I'll see you in class.